Welcome to Alexa Tech Talks. My name is Eric Fahsl, and I am a Senior Solutions Architect with the Alexa Voice Service. Today, we're going to be talking about Smart Home over AVS. To demonstrate, I have here an AVS device, a Sonos One speaker with Alexa built in. And over here, I have a smart light bulb. Now, the two can work together, such as Alexa, set office light to green. Cool. Now, normally these are distinct integrations. This is an AVS integration involving the microphones, the speakers, and communicates with the Alexa voice service. Whereas this device communicates with a smart home skill and requires a customer to enable the skill, perform account linking, so that when the devices are on the same account, they can be controlled. But with Smart Home over AVS, you can have this type of device control capability onto your Alexa built-in device. For an example, let's take a look at an LG TV in my next room over. Welcome to my living room. I have here an LG Nano 85 Smart TV with Alexa built in. Now this TV, like a number of other LG TVs, does have a smart home skill that you can enable and authenticate to, and which allows you to voice control various aspects of the TV, things like power, input, and channel, from a companion Alexa device, something like this Echo Dot. But this device also has Alexa built in. Let me demonstrate. How far away is the moon?
Today, the moon is 232,800 miles from Earth.
Cool. Now LG was able to take the Smart Home over AVS pattern and implement some of those smart home controls straight through the Alexa voice service. Let me show you. Change input to HDMI 2 on TV. Now in my setup, I have a Roku device connected to HDMI 2. Additionally, because a smart home device was created on the account, I can also use any Alexa device on my account to control the device. For example, let me turn on this Echo Dot. Alexa, turn off the TV. And there we go. So that was pretty cool. Now, this doesn't have to apply to just TVs. It can apply to a variety of device types. It could be something like a Raspberry Pi. It could be a little IoT kit. It could be a USB light bulb. And even later, I'm going to show you how I actually used this capability to control some properties on my Mac laptop. In today's Tech Talk, we're going to be talking through 3 different ways of how you can implement this. The first with the AVS device SDK, the second with AVS integration for AWS IoT, and the third is by using the AVS APIs directly with a sample project in NodeJS. So let's take a look. First, AVS is the Alexa voice service, and it is available on a variety of device types. We saw earlier my Sonos One, we saw the LG TV, so those are smart speakers and TVs, but they're also available on things like soundbars, on laptops, also other smart displays like a Lenovo tablet, Facebook Portal, also on-the-go devices, things like earbuds and headsets. So you can actually basically talk to Alexa no matter where you are. And then Smart Home is, of course, many device types, thousands of different device types, light bulbs, switches, cameras, thermostats, all sorts of different things. But the main thing that's linking them is that most of these are smart home skills, that you go to your Alexa app, you enable the skill, you authenticate, and now you can control that device from any of your Alexa devices on that same account. So let's talk through how the Alexa voice service works. Walk through a simple example. You may have seen this before, but if I were to ask for the weather, there's a variety of things that happen. So first, when I speak to the device, first I'm usually going to say Alexa to speak to it hands-free, and the device is going to wake up and start streaming the audio of the noises coming out of my mouth to the device, and it's going to start processing that to determine what it is I'm saying. So it's going through speech recognition or automatic speech recognition, and then NLU, natural language understanding, to determine that the customer is asking about the weather specifically for tomorrow, and they're also interested about rain. So based off of that, Alexa is then going to determine how to handle that, as in, let's call the weather service for the customer's location, for the date, and determine what the forecast is going to look like and answer their question about rain. Now, with smart home, when I try to turn on the lights, it's going to go through that same process. It's going to go through the speech recognition, natural language understanding, but the difference is that it is going to be looking on my customer's account, my account for living room or living room lights. So is that tied to a group? Is that tied to a specific name? And then what device or devices are associated with that living room, or the lights of the living room? And then Alexa is going to send a command or directive down to these third-party device clouds, to basically control those lights. So the reason I bring this up is that for smart home over AVS, we're actually taking both of those patterns and simplifying into one. So rather than having this third-party device cloud for controlling our devices, we're actually going to send a command or directive back to our Alexa built-in device for that command, whether it's turning on the light, adjusting a mode, etc. So it offers a real simplification. So there's a few benefits to this. For the customer, it means they only have to authenticate once. They don't have to go to a separate third-party skill. They don't have to go to the Alexa app, enable the skill, and perform account linking. Once they authenticate with the Alexa built-in device, they already have voice control for their device. So that's neat. Also for the developer, they don't have to set up the infrastructure. They don't need to create the separate Lambda function, perform the account linking, and probably the biggest cost is having this separate third-party IoT device cloud. So it offers a real reduction in development cost and perhaps resources. It's also potentially easier to debug. You're dealing with basically one system, one device, instead of multiple systems with multiple points of failure. And then finally, there is a little bit lower latency. Certainly when you have, again, it's going straight back from the Alexa cloud back down to the device versus going to a third-party, going to your Lambda function, third-party cloud, and then so you're reducing steps, so it's a little bit lower latency. Now, there are a few reasons why you may not want to use smart home over AVS. If you already have a device cloud, maybe you've already solved some of the heavy lifting of trying to set that up. Or if you already have a smart home skill, you may not get a ton of extra benefits of using this. Or if you need a custom skill, not just a smart home skill, you need to make your own intents, your own interaction model. This isn't really going to help you. And then finally, if you want to use your device with voice control on more than just Alexa, this isn't necessarily going to help you. We realize there are multiple voice assistants out there, and this is going to be Alexa specific. So there are some reasons why you may not take advantage of this. So let's look one level deeper now at AVS and smart home. When you communicate with an Alexa voice service device, it's going to be using what's called events and directives. So events is communication going from the device out to the Alexa cloud, and directives are going to be instructions from the cloud coming back down to Alexa. So for example, when you speak to Alexa, it's going to be using what's called a speech recognizer event, and when Alexa is responding or doing what we call TTS or text-to-speech, it's going to be using the speech synthesizer directive. So just remember that, events and directives. Now, for a little background on smart home, if you've never dealt with it before, it might seem intimidating at first. There's a lot of documentation, but it's actually not too bad. It's relatively simple. First is you have to understand there's a variety of capabilities that are defined. So things like power, percentages, colors, ranges, etc. So first you just need to determine which of these type of controllers does your device support. As for device types, it could be appliances, thermostats, security, lights, etc. And various interfaces are relevant to certain device types. The next thing your smart home device needs to be able to do is create what's called a discovery response, or respond to a discovery request. So when a customer asking, discover my smart home devices, basically your skill, or what we'll get to at our AVS device, will basically need to declare what type of interfaces it supports. So does it support power, range, etc.? And along with those, the parameters for each of those. And then you need to be able to respond to commands, so directives, like a power controller.turn-on directive indicating turn it on, or a range controller.setRange trying to set a value, and that could either be a absolute value, like setting the value to 3, or it could be increasing the value. It could be like a adjust range +2, -1, etc. So there's a variety of different controls that your device will need to be able to respond to. And then finally, there's something called what we call device state management. So when you use the Alexa app, you'll actually be able to see what the different controls are for that device, and you can actually modify those values with the app itself, and you'll want to be able to reflect the state of those values. Now with smart home, let's take an example of something called a power controller, so turning something on and off. So when I ask to turn on the light, like I said, it's going to go to the cloud, perform NLU, and then determine what type of device to handle that, or rather what skill is going to be, and what Lambda function is going to be sending. So it is going to send a power controller directive to the skill, along with an endpoint, basically saying that this customer is requesting to turn on this device ID. Partner, please go and through your device cloud, find that device, send the command to turn it on. Once it does that, it's going to confirm with Alexa that, yes, I was able to turn on the light, so that Alexa can then respond okay, or with what we call an earcon, a confirmation message. And that confirmation is important because, I don't know about you, but sometimes if I go into my basement, I ask to turn on the lights, and it says okay, but I'm still standing in pitch black, it's kind of annoying, right? So it's important to have the proper success or failure messages for Alexa to convey to the customer. Now with smart home over AVS, let's say our device implements a power controller, whether it's a light or something similar. So when we ask to turn on the light, the Alexa service is still going to send a power controller turn on directive, but rather than sending it to the cloud, it's actually going to be sending it straight back to our device. So our device, instead of having a speech synthesizer directive to play back speech, it's actually going to be receiving this power controller directive indicating the desire to turn the device on. So in the same application that is building both the Alexa voice service, we can also implement smart home logic to perform controls on the device. All right, that's enough foundation for now. Let's talk about how you can begin. So as I mentioned, I'm going to be on 3 different integration options. The first is the AVS device SDK written in C++, which we would recommend for most AVS or Alexa built-in devices. We recommend starting there first. And then we also have the AVS integration for AWS IoT, and this is for more limited resources or perhaps smart home first devices. And the language is using things like free RTOS and perhaps others. And then finally, this last category I'm calling Micless devices or apps. And this is intended for companion devices or prototypes. And the language, I'm going to be showing you a sample repo in NodeJS, but it's really any language you want, anything that can implement HTTP2. So let's dive in. So let's start with the AVS device SDK. It is available on GitHub, and it is certainly our recommended approach towards building your Alexa built-in device. It is a flexible, modular SDK that provides Alexa voice interaction, basic music support, alerts, alarms, notifications, your network connection, multi-room music, Bluetooth management, quite a bit. basically, the Alexa voice service has all of these different interfaces, all these different capabilities and state management that your device needs to be able to handle. And the AVS device SDK has capabilities for just about all of that. And it is continued to be updated. So if you're a device maker, Alexa built-in device maker, start with that. We have a lot of materials available on this. So on our developer documentation, there's also various overview videos describing all the different components, how to modify it, but it also supports smart home over AVS. And the simplest way to enable that is when you build your SDK is you can use this additional parameter, enable all endpoint controllers equals on. So there's more information on the documentation. It's actually going to create two endpoints. There's going to be the peripheral endpoint called Disco Ball, and will also provide some smart home controls on the base endpoint. And you'll actually be able to see both of these in the Alexa app. But rather than me talking more about it, how about we dive in? All right, so let's take a look at the AVS device SDK. So on here, I have the GitHub page of the AVS device SDK. And there's plenty of information on here, including release notes. As you can see, it's updated fairly frequently. There's also some additional information on the SDK architecture, including all the different components that are available. There's also a link on here that talks about the smart home endpoints and how you can enable that. For instance, by doing these enable all endpoint controllers equals on. In fact, actually, in April of 2020, certain somebody, myself, created a blog post on how you can do this. And there is also some more information from one of my colleagues on how you can modify the components within the SDK to do this. I bring this up because I'm trying not to rehash everything, but rather just focus on the highlights. So if we were to jump to our SDK, and look at the sample application.cpp, we're actually going to see a variety of things in here related to controllers. So where our toggle controller, range controller, etc. is found. But the main thing is where we start declaring the endpoints. So for instance, the friendly name of Disco Ball. Some description, also some of the capabilities such as light, brightness, mode, serial number, etc. So all of this is declared in the sample application.cpp. Let's go ahead and build it now. I've got my command saved here, so I'm going to run this, and then we'll speed it up. Okay, now that it's built, I'm going to go ahead and open up my app here on my phone. I'm going to mirror to my screen, because when I launch the sample app, it should tell us that a new device has been found. Oh, there we go. New device name Disco Ball. So let's go ahead and try it. Let's say, Alexa, turn on Disco Ball. Okay, so what happened was, I'm going to scroll up my logs here. So it's printing out a message. So first of all, we received the directive, Alexa power controller, turn on. And we see here that it's the peripheral endpoint, in this case, the Disco Ball power state is now on. What we can also do, so that was by voice, we can also see this in our app. So first of all, when I open up the device here in the app, it's actually going to be looking for a report state. So it's going to be querying, the app is triggering a query to the device to retrieve the states. So right now it's saying that the power is on. So if I tap the button to turn it off, we now see the endpoint Disco Ball state is off. Sorry, went away pretty quickly. Likewise, I can change the mode. Let's change from red to green. And now we see that the mode is changed to green. So cool. Now, it's just printing out things on here. It's not necessarily overly useful. So that's why I have this little USB light bulb here. It is a ThingM light bulb. We'll share the link later. And basically, I just want to show some of those controls from this SDK actually controlling here. So in the sample app, in the peripheral endpoint power controller and the mode controller, I'm going to modify those. So what I'm actually doing, now this is very much a hack. It's cheating. Basically, I'm executing this blink tool as a command line. I'm just saying for power, if it's turning on, turn on the power or turn off. Likewise, for the modes, what I'm going to do is I'm going to set the colors to red, blue, or green based off the sample values that are available in the app. And I'm going to go ahead and rebuild that build. Okay, now that we're done building, I will go ahead and relaunch the SDK. Now let's try to turn on our disco ball and see what happens. So I would say, Alexa, turn on disco ball. And it turns on. Great. Likewise, Alexa, turn off disco ball. Cool. Now let's try from the app now. So let's see if we can set one of these modes. So set it to green, try with voice, Alexa, set disco ball to blue. Great. So this is the AVS device SDK. Again, it has some built-in logic. All of this is handled. It's in this sample app, and it's using a variety of the capability agents as defined. So like, mode controller, power controller, etc. These are all defined, and there's plenty more information within the SDK. And again, I'll provide the link to my colleague's blog article on how you can modify the various capability agents to extend this in a more meaningful way than what I was just doing, which was system commands. So let's move on to the next one, shall we? So this next pattern is called AVS integration for AWS IoT Core. And this is intended for devices that may be lower power, less RAM, or perhaps smart home first devices that perhaps already have a connection with AWS IoT. One example is this AWS IoT EduKit that was just released at reInvent in end of 2020. And what this is primarily it's intended to connect to AWS IoT. It has a variety of sensors, including a microphone, speaker, temperature sensor, accelerometer, and some LED lights on the side. And while this is not just intended for Alexa, there's a variety of things you can do with it, but adding the Alexa voice assistant was something that was relatively easy to do, even on an embedded device like this. There's actually a whole workshop that talks about that, on how you can add Alexa voice to this, along with other tutorials. But along with that, the Alexa voice service there's also the smart home over AVS capability. It's in preview state as of this recording, but it's still interesting to see, and you can there are some common trends with that. So like if I were to jump to some of the code that's being used, we can see that there are some similarities in terms of when the various smart home controllers come in and how they're handled, as well as the declaration of the device, like the friendly name of light, declaring a power and a brightness controller. I don't have a ton more to say about this pattern. We're not going to dive too deep into it. There's plenty more documentation on the AWS website. I mainly wanted to point this out to say that there is another pattern, such that if your device can't run the standard AVS device SDK, you can use this AVS integration for AWS IoT Core, which is going to actually offload some of that functionality to the cloud and still let you have voice support, while also still letting you do smart home over AVS for device controls. So let me show you some examples of this device in action with Alexa. Alexa, tell me an interesting fact.
Here's a fun fact about animals. An octopus is known for its 8 legs, but it also has 3 hearts, one to pump blood through the body, and 2 others to pump blood through the gills.
So here we have the same device, and we've got the Alexa app open to it. So we can turn on the green light on the side. And we can also adjust the range. We set up a range called blink, which will control the number of times it will blink. This, of course, will also work by voice. Alexa, set blink to 7.
Okay.
Now let's take a look at our third pattern for Micless devices or apps. So it's built in Node.js, and basically what it's doing is it's implementing those various APIs to the Alexa voice service, but there's no it's not implementing the voice APIs. So what you'll do is if you follow the instructions on the repository, you'll basically create your own AVS device, and you will modify it's called the security profile to allow going back to your local host for authentication. And so basically this is really meant for prototyping, but this is a really great way to learn more about the service and about the events and directives, so that you could then build out on a more productionalized product, or there's also even learnings you can take from this to the regular smart home skill API. So I've already checked out the repository, and essentially it's going to be a bunch of predefined JSON responses to various things. So what it's going to do, it's going to create a discovery response with a light called living room that can use Power Controller. So in order to do that, first we need to authenticate, and this is actually the same for any AVS devices, that the customer is going to need to authenticate in some way. And there's a variety of different ways. There's something called like a code-based linking that was done on the AVS sample app or done on TVs, or you could use like a mobile phone as a companion device. So there's a variety of ways that you can actually authenticate. So why don't we go ahead and I'll show you the authentication piece. So first of all, when you do this, it's in this code, it's actually going to open up a browser window, and I'm going to go ahead and authenticate. And because I've already authenticated this device, it may skip a question or two, as in, do you consent to Alexa voice service, et cetera, et cetera. In this case, I've already consented, so it's not going to re-ask me, but it's saying that it's complete. And what this is doing is this is setting the access and refresh tokens that's being stored basically on my system, so that I can authenticate to the Alexa voice service. So now I have my gateway up and running, and there's a couple events I can do. So I can either do a issue discovery request, also called an add or update report, or a proactive state update. So let's go ahead and do the discovery request. So I'm going to open up my app on my phone, mirrored to my screen, and when I do the discovery, it should say there's a new device found. Okay, called living room. So that maps to our discovery request that we have defined here, discovery.json, basically a living room and has a power controller. So if I go to, let's find that living room device. So first of all, on here on the right, it's going to be printing out any incoming directives and printing out the corresponding event responses. Now, because I have the app open, it's going to continuously keep pinging it, see, with the report state. Now, what I will do is, if I hit power on, so what's happening is it's receiving the Alexa power controller turn on. much like we saw in the SDK earlier. So basically, this isn't anything really new or different. It's just that we can actually, with just a couple of a relatively lightweight client, we can actually implement an application that can send and receive those events and directives in a format that's pretty easy to understand. JavaScript and JSON is very easy, perhaps a little bit quicker, faster to manipulate than with like the device SDK and C, C++. So this is one of those benefits of that. So what I'd like to do now is, well, what can I make this something a little bit more useful? Can I turn my Mac OS system into a smart home device? So what I have done is so I've actually forked the repo in a separate one, and I'll give the URL. But basically, I've modified a couple of the attributes to work with Mac OS. And so let's start by looking at my discovery request. Sorry, that might be a little big. So with the discovery, and JSON can be a little bit hard to read, so I apologize for that. But I wanted to call it a couple things. So first of all, I'm creating a device with a friendly name of Mac, and giving the description, calling it, I guess, Amazon's manufacturing, but the different display category. And the interfaces I'm using are toggle controller for a screensaver. So I wonder what we could be doing here. So in here, we've declared a friendly name in the ENUS, English US locale, and I've also defined something called a semantic annotation here, which is saying open, mapping to turn on. So what could that be? So what I'm trying to say, basically, I'm supporting the command of open screensaver on Mac. And then finally, the other attribute that I've implemented on this is a range controller. So numeric range between, I think I did 1 and 10. From 1 and 10, called brightness. So I'm able to set the brightness of 1 to 10. Wonder what that could be. So let us go ahead and build this, and let's see what it looks like. So I have my Mac smart home device open here on the app on the left, and I have my NodeJS client running on the right. Currently it's responding to state reports since I have the device open on the app, and I can adjust these values by voice, such as Alexa, set the brightness to 3 on Mac.
Okay.
And I can also adjust it with the slider, and it will update. And what's also neat is I can, if I adjust the brightness from the PC itself, it will also, as part of the state report, update on the app too. And finally, I can start the screensaver by saying something like, Alexa, open the screensaver on Mac.
Okay.
And the screensaver is launched. So I have one more demo scenario to show with you. So recently we had a little hackathon, and I basically took the same concept of the Node.js Smart Home over the AVS project and put it into an app built with Unity. And I had implemented a little bit of some in-game controls, but also because this was a smart home device, I actually was able to tie some of the actions of the game into routines that would synchronize with the smart home devices in my home. So there was some some synchronization between the virtual game world and the physical world, which was kind of neat. So let me show you.
Warning, low health detected.
So there you have it, 3 different ways on how you can implement Smart Home over AVS on your device or application. Be sure to check the documentation for details on each of the different interfaces. We hope you learned something in this tech talk or been inspired to add voice controls to your own devices or apps. Please take a couple of minutes to tell us what you thought of this session by completing our brief survey. Stay tuned for more exciting tech talk content coming up in the near future, and happy building!